Okay, so this is the Chapter 3, Section 7 notes. We've worked with absolute value before. It was in Chapter 1 where we were taught the absolute value of a number is how far it is from 0. Because of that, we learned that absolute value was always represented as a positive value. There were some tricky portions of that work, but the general idea was that any negative inside the absolute value symbols disappeared. That was the one where I said that the negatives, or that the absolute values were kind of like a washing machine and the negative was inside the machine and came out. So a couple problems you saw was that with this negative being inside the machine, it came out as a clean or positive 9, and that with this negative in here came out as a positive 13, but what happened on your test was that that negative was not in the machine, and so it made a negative 13. So again, that was kind of what we did with absolute values. But think for a second about solving this question in your head in terms of the absolute value of something being 6. There should be the obvious answer of 6, but we have to keep in mind that we could also place a negative value inside of parentheses, which means that a second solution is negative 6. So your two answers would be x equals 6 and x equals negative 6. This represents the only new information for the lesson, and that is because the absolute value eliminates a negative inside of its bars. There are actually going to be two possible solutions to every question. So look at the following examples real fast just to see how I solve them. If you were asked to solve absolute value of x equals 3, you would simply say x equals 3 and x equals negative 3. If you were asked to solve absolute value of x equals 11, you would simply put x equals 11 because that's the obvious answer, and x could also be a negative 11 because that negative would disappear. Tricky part though, is the absolute value of x ever going to be a negative? And in situations like that, which you'll rarely see, there would be no solution. There's nothing you would be able to put into that question, into that bar, that would cause a negative answer to come out. But other than that, the main thing about the two different answers is what you are thinking about the most. So keep in mind there are also inequalities involved in our work. This means that we must adjust our thinking for the new symbols. It'll take some memorization on your part, but it's still basically simple. If the problem is a less than symbol, in other words, if it is pointing at the bar, then we will simply rewrite this by putting a negative 4 in front, a regular x, and a positive 4, or a regular 4 on the other part, with the symbol being repeated in between. So notice that this symbol is repeated. All we did was put a negative in front and go that way. If the problem has a greater than symbol, in other words, if it's pointing at the number, then we separate it into two things, whereas we simply ignore the bars the first time. We put the word or, we ignore the bars the second time, flip the sign and the sign on the number, so we switch the inequality and the sign on the number for our two equations that we are looking at. So this is what you'll have to kind of memorize, and we'll talk about that in just a second. But again, notice that the first symbol is pointing at the absolute value symbol, and that is kind of a way to remind you that it's the easy one where you can simply put the number on both sides. But again, the more you practice, the more you'll get better at it. Outside of the general ideas, this represents the summary of your information. So absolute value of x equals 5 is changed to these two things. So you ignore it, put a positive 5, ignore it, put a negative 5. Absolute value of x is less than 5, where it points at the bars, is changed to putting a negative, copy the symbol, regular x, copy the symbol, and a regular 5. And if it's pointing at the number, that you will put the regular part without the sign, which is x is greater than 5, or you'll keep that, switch, and switch for your second equation. So you may want to write those three situations down, because that again represents your general information for the day. And once you get that, everything else is just a matter of solving, kind of like we've been doing the last few days anyway. So let's get to some notes real fast before we move on. Here you have one absolute value of 1 minus 2x equals 9. Again, you cannot solve with the absolute value bar, so the first thing you do is you ignore the bar and put a 9. Keeping in mind that this can be positive or negative 9, we put and, we ignore the bar again, 1 minus 2x, and we then put a negative 9. Because remember that there are two possible answers to this in many situations. Now we solve it. We will subtract 1, getting negative 2x is equal to 8. I still switch the signs no matter what, but equal sign does not switch differently. It still looks the same. Then I would divide by 2, getting x equals negative 4 as one of my answers. Then I simply come over here and do the same thing, subtract 1 from both sides, getting negative 2x equals negative 10. I don't like the negative 2, so I again switch the signs. Then I divide by 2, getting x equals 5. as my final answer there. So that represents my two answers. If I put a negative 4 in there, that makes positive 8, because you got negative 2 times negative 4 plus 1, which makes 9. If I put a 5 in there, you have negative 2 times 5, which is 10. Or sorry, negative 10, and 1 minus 10 would be your negative 9, which comes out as a positive 9. So it does work. This is again where you have to kind of think a little bit, because now that you have an inequality, we have to make sure we pick the right one. Here, this is not pointing at the symbol, which means this is the one where I ignore the sign first. I use the word or, and then I ignore the sign again, but I switch both things. So I switch this around and I make my 8 negative. From there, you simply solve as usual. So 3t would therefore equal, or not equal, it would be less than or greater than 7. Then when you divide by 3, you get t is greater than 7/3. Over here we go to solve it, we subtract 1 from both sides, we get 3t is less than negative 9. Divide both sides by 3, getting t is less than negative 3. The negative is obviously smaller than the positive. If you were wondering what that number is, that's about 2 point something. But either way, this is an open circle here pointing to the left. This is an open circle here pointing to the right, and that would be your graph for that answer if you had to do that. Again, the general idea here is make sure you learn that if it's pointing at the number, you do two different numbers or two different equations for that. Looking at number 3, this symbol here is pointing at the actual symbol, which means this is the one where I simply put a negative 9, copy the symbol, ignore the bars, copy the symbol, regular 9. This is a AND equation. Again, if it's pointing at the symbol, then this is what you're going to do. From there, we solve the way we learned yesterday, which is to add 5 all 3 times, getting negative 4 here, 2c there, 14 there. Divide by 2 3 times, getting negative 2c and 7. And again, because c is in between them, we put our circles, which are closed because they are greater, less than, or equal to both of them, and you shade the middle because c is in the middle. So that represents the majority of what you need to know, and then you have the trick questions that you have to be ready for, which we will do on 4 and 5. Now, the best way to think about absolute value bars is that you are changing out of the absolute value bars to create this situation. And the way that I think about absolute values so that I remember how to do it is with stupid stories, of course, but I would imagine that the absolute value is like Superman. And I remember that Superman would not change, Clark Kent would not change into Superman in front of everybody. He would need everybody to be gone. So what this bar is going to do is it's going to say, I'm not going to do anything until everybody is on the other side, because I don't want anybody to recognize me changing. And so what you have to do is ignore the changing part of this and get rid of everything on the outside first. So imagine this was an X. So you would move this 3 first by subtracting 3. And again, everything else comes down. Second thing is we have a 2 on the outside of the bar, which we will divide by 2. Everything else comes down. And now that everything's gone, you saw it the way that we did before. So again, we had to get rid of the 3 first using algebra the way we know. We had to get rid of the 2 first using algebra the way that we know. And now that we have the bar all by itself, we can do our work. This is pointing at the bars, which means that it's going to be negative 6, copy the sign, ignore the bars, copy the sign, write down your 6, and solve the way that we've learned to solve before. Graphing this, negative 7 goes over here, 5 goes over there, and because x is in the middle, we shade the middle. So again, if you see a question where the absolute value bar is not alone on one side, you have to get the absolute value bar alone before you do any of the other work that we just learned. So that's really the only trick problems in this. Looking at number 5, same situation. I have an absolute value, but I have numbers mixed in with this absolute value, and this absolute value bar is not going to change with other people in the room, so we have to get them out. And so the first thing we do is we move our 5 by subtracting, keeping everything else the same. We move our 4 by dividing, keeping everything else the same. And now that we have the bar by itself, we solve by what we know. Notice again, this symbol is pointing at the number, and so that means this is the one where I have the or. So h minus 3 is greater than 2, or h minus 3, switch the sign and switch to 2 for your second equation. Solving the same way we've known to solve, which is to add 3 to both sides, we get h is greater than 5. Doing this one here, we get h is less than 1. Putting the numbers in order with 1 over here, 5 over here. 1 is a open circle pointing to the left. 5 is a open circle pointing to the right. And that would be all you have to do. So again, today when you see these questions on your quiz this week, when you see these questions, make sure you remember this. And again, you do have a quiz on this tomorrow, so make sure you practice this stuff so you can put it all together. And this quiz is over everything you've done so far, so that I can see who knows what and who is lost and who needs assistance. So go ahead and log into your MathXL and continue working. Remember, if you finish up this section of questions, you want to make sure you go backwards and start wrapping up some of your old stuff, because your deadline for MathXL and all of your tests and quizzes is Friday. So you might want to make sure you start knocking those out. Good luck.